Hello and welcome to Excellent Link Academy. For today's class, we're discussing about the study of trigonometry as a course. So let's discuss about trigonometry as a course. All right. I'll be trying to create a playlist, right? A full course tutorial video on trigonometry ratio, right? So you can do well to check our YouTube page and check our playlist. In the playlist, you see a designed series of video for trigonometry as a beginner. So if you are trying to understand the concept, the full concept of trigonometry as a course, you can actually do well to check our playlist and download the video. The video are arranged accordingly. What you need to know before the order. So the video are arranged accordingly. All right. If you're also new to my channel, I would like you to do well to subscribe, hit the bell icon so that you'll be notified whenever you drop any video on trigonometry. All right. Let's dive into the study of trigonometry as a course. By definition, trigonometry is simply the ratio of right angle triangle, right? In general, trigonometry can also be called trigonometry ratio. So it is widely accepted worldwide as trigonometry ratio. So either they call it trigonometry or perhaps you call it trigonometry ratio. Having understand the concept behind the definition of trigonometry, let's understand something called the hypotenuse, opposite, and adjacent. All right. When it comes to trigonometry, the basic diagram I'll be masking out is what? The right angle triangle. Why? Because I just said that trigonometry is simply the ratio of right angle triangle. That is to say, any diagram I'll be drawing here are just majorly what? A right angle triangle. At this point here, considering a right angle triangle, as in this case, let's say I have a right angle triangle. Let me call here my angle theta. From here now, if I'm calling it an angle theta now, first, note something that the longest part of a right angle triangle is called the hypotenuse. Wherever this angle is facing here, this becomes what the opposite, while this one here becomes the adjacent. So know how to label the concept of hypotenuse, opposites, and adjacent in the concept of what? Right angle triangle. So for this right angle triangle here, my angle is facing this side. This becomes the opposite. The longest part is called what? The hypotenuse. Automatically, the left part is called what? The adjacent, which is this. So if I'm given a right angle triangle, as in this case, my priority, let's say my angle is at this point now. My priority is to get two things. What and what? The hypotenuse and the opposite. So the left one will become the adjacent. From here now, my hypotenuse is the longest side here. So this one becomes my hypotenuse. The angle is facing down here. This becomes what? The opposite. Automatically, this one left is called what? The adjacent. All right. At this point now, I will understand the concept of definition of trigonometry and how to insert the concept of hypotenuse, opposite, and adjacent into a right angle triangle. Let's discuss something very important called special function of angle. Special function of angle. Let's discuss special function of angle. All right, at this point here, when it comes to the study of special function of angle, there are about 6 angles there, so which I'll be giving you now right now. All right, the special function of angle goes below. The first one there is called sine. The second one is called cosine, tangent, secant, cosecant, and finally we have called cotangent, please. Cotangent. So when it comes to the concept of special function of angle, this ranges from the sine, cosine, tangent, secant, cosecant, and cotangent. These are about 6 special function of angle that we have here in front of us. So at this point, let's say I have a right angle triangle, and the angle I'm considering is theta. So it means that I'll be having sine theta, cos theta, tan theta, sec theta, cosec theta, and cot theta. So because I'm considering angle theta, so this becomes theta all through. If I'm considering alpha, this becomes alpha. If I'm considering beta as my angle, they become beta. All right, this is like the concept behind special function of angle. All right, let's discuss the next concept called the concept of SOH CAH TOA. Concept of SOH CAH TOA. Let's discuss the concept behind SOH CAH TOA. The concept behind SOH CAH TOA goes below, right? Majorly, at this point now, let's say I have a right angle triangle. Observe, please. A right angle triangle, as in this case. Let me call a point A, point B, and point C. Point A, point B, point C. Distance between A, B, let me call it X. Let me call it Y. Let me call it Z. Let's see, I'm considering the angle to be here as angle alpha. Let me not use theta. Let me use alpha in this case. So I'm given this diagram here, a right angle triangle. Let's start considering the first one called sine. Let's start with the first one. So let's start with the first concept there called SOH. What's the concept behind SOH? The concept there is that I have S stands for sine, O here stands for opposite, and H here represents what? The hypotenuse. So in this case, that is to say, I'm saying that the sine of what angle? Of alpha. The sine of alpha is equal to what? The opposite all over what? Hypotenuse. That becomes the concept of SOH. So it means what? The ratio of opposite to it, what? The hypotenuse. Let's get something right. For this diagram here, where's my opposite? We said opposite is simply where the angle is facing. Opposite is where the angle is facing. The angle is facing here. This becomes my opposite. So I'm having my opposite to be what? BC. My opposite is what? BC. So I have BC all over. What's hypotenuse? The longest part. The longest part. Check here. The longest part is what? AC. So my hypotenuse here is what? AC. Now at this point, note that therefore I'm saying that sine alpha, which is this, is equal to what's BC? BC is Y. Y all over what's AC? AC is Z all over Z. This is the first thing you need to note, right? Number one, note this one, please. Number one. Number two, there, let's discuss the concept of CAH. Let's discuss the concept of CAH. For considering CAH, this C here signifies what's it called? Cos. So so at this point here, the short form of writing sine theta becomes sin. So these are the short form of writing this stuff here. Cosine is cos, tangent is tan, secant is sec, cosecant is cosec, cotangent is what? Cot. Right? So like the short form of writing this thing here. Alright, this is adjacent here. This is hypotenuse. So I'm saying now that the cos alpha, which is the angle I'm considering here, is equal to adjacent, the ratio of adjacent to what? To its hypotenuse. Help me check what's my adjacent from this figure here. That's AB. So I have AB all over hypotenuse, please. The longest part, that's AC. I have AC. So therefore, I'm saying that the cos alpha is equal to what's AB? AB is X here. That becomes X all over AC. AC becomes Z. So this becomes the expression for what's it called? CAH. So note this expression for CAH. The third what's it called? Concept you need to note is what we called TOA. This T here signifies tan. This O here signifies opposite, while this A here signifies the adjacent. Let's get it right. This means tan alpha is equal to what? Ratio of opposite all over adjacent. So what's my opposite here? Opposite is where the angle is facing. The angle is facing here. For this case, my angle is facing here. It becomes what? My opposite, that's BC. I have BC all over. Adjacent is what? The baseline here. That's AB. AB. So therefore, I'm saying that tan alpha is equal to what? What's BC? BC is Y all over what's AB? AB is X. So tan alpha is the ratio of Y over X. These are like the three very important stuff that you need to note when it comes to the concept of SOH CAH TOA. Alright, all these things are like pieces. As I said earlier, I'll be combining. At the end of the class, I'll combine them to make sense. Alright, let's proceed here. Let's discuss something called inverse of function of angle. Let's discuss the inverse function of angle at this point. Alright, at this point here, there are about three distinct inverse function of angle ranging from the ranging from secant, cosecant, and cotangent. So the first one there is called secant. Secant what? Secant alpha, because my angle here is alpha. The angle I'm considering here is alpha. So secant alpha now is equal to what is short form of writing secant? That's what? Sec. So that becomes sec alpha, which is equal to, observe please, what's the mathematical expression for sec alpha? Sec alpha, it can be represented as what? Observe, this is S, E, C. This is C. There's a kind of trig that represents C. That's what they cos. So therefore, the mathematical expression for secant becomes 1 over cos alpha. 1 over cos alpha becomes the expression for secant alpha. I just showed you why. This is C. This C ended, that becomes cos. So that becomes 1 over cos alpha. So I'm saying that sec alpha, which is equal to 1 over cos alpha. This can be expressed as this is 1 all over what's cos alpha. We just established that cos alpha is x over z. So I'll have x over z. I will show you a shortcut which I'll be using throughout now. So instead of using baby mass, I would show you a shortcut. I'm having 1 here divided by x over z. What's the shortcut? What we know before now is that this becomes 1 times this one comes up, this one goes down, right? What we know. So 1 times z is z all over this x. So this becomes x over z. So the idea is that if I'm having 1 all over a fraction, the last one of the fraction comes up, this last one, z times 1 becomes z all over this x. That's the shortcut. So at this point now, I'll not start using this expression. I'll start using shortcuts. What's the shortcut? If I'm having just a number and if divided by the fraction, the last denominator comes up as z, and I have this one left. All right, let's proceed from here, please. At this point, therefore, I'm saying that secant alpha is equal to what? Z all over x. So note this one as the very first stuff you need to note when it comes to inverse of function of angles. Number 2 there, I see there are about 3. Number 2 is called cosecant alpha. What's the short form of writing secant? We just said that the short form of writing secant is what? Cosec. So it means that I'll be having cosec alpha, right? What's the mathematical expression for cosec alpha? This becomes 1 over 1, 2, 3. This is sine now. That becomes sine alpha. So the mathematical so this one becomes the mathematical expression for cosec alpha. So I'm saying that cosec alpha is equal to what? 1 over sine alpha, which can be broken down as 1 over what sine alpha? Sine alpha is y over z. So I have y over z. So therefore cosec alpha is equal to what? Z all over y. Another very important concept to note. I explained I explained this concept now earlier, so know why I'm having x over y, please. Don't ask me that it is y over z. Why is it z over y? I explained earlier now. All right. Number 3 there is what we called cotangent. So the third one becomes tan cotangent. So cotangent what? Alpha. The short form of writing cotangent becomes what there? Cot. So have cot. What's it called? Cot alpha. So when it comes to cot alpha, this becomes 1, 2, 3. This is tan. So this becomes 1 over tan alpha. Just count 1, 2, 3. This is 1, 2, 3. 1, 2, 3. So the last stuff becomes their ratio. So I'm saying that cot alpha is equal to what? 1 over tan alpha, which is equal in value to 1 over what's tan alpha? Tan alpha is y over x. That's y over x. So therefore, I'm saying that cot alpha is equal to what? X over y. Note this expression. Alright, I don't understand the concept of inverse of function of angle. Let's discuss one last thing. Two last thing, right? Two more last thing. Then we end today's class. Let's discuss two concepts and end today's class. What are these concepts? Case case 1. The two concepts include case 1 and case 2. For case 1, divide sine alpha by cos alpha. So for case 1, I am dividing sine by cos alpha. If I divide sine alpha by cos alpha, what do I get? So sine alpha is what? Sine alpha is y over z. So I have y all over z as sine alpha all over what's cos alpha? Cos alpha is s over y, x over y. Let's break this down. This becomes y over z divided by what? X over y. True or false? Sorry, cos alpha, x over z, x over z, x over z, x over z, right? All right, from here now, let's break this down. This can be broken down as y over z multiply, this one comes up, this one goes down, this cancel this. It means that if sine alpha divide cos alpha, this will be equivalent to what? Y over x. But what is y over x? That's what? Tan alpha. Check. Y over x tan alpha. So I'm saying that tan alpha now is equal to the ratio of what? Sine alpha all over cos alpha. This is for case 1. Note this mathematical expression. For case 2, for case 2, I'm going to be dividing cos alpha by sine alpha. So if I divide cos alpha by sine alpha, I have cos alpha all over sine alpha. What's cos alpha? That's x over z. X over z divided by sine alpha is x over y over z. So this becomes x over z, divided by y over z. So this becomes x over z times what? Z over y. Z cancels z. So it means that cos alpha over sine alpha will give x over y. X over y. So, but what is x over y? All right. Instead of squeezing it here, right? Let me just make them. Let me write it there. Alright, from here now, so breaking this one down, sine cos alpha all over sine alpha will be equal to x over z times, this one comes up, z all over, this one goes down over y. This one comes up, this one goes down. So this one cancel this. So cos alpha all over sine alpha is equal to x over y. There's kind of expression, but x over y is equal to what? What's x over y? X over y. x over y, x over y. That's cot. Can you see that? That's cot. So this becomes cot alpha. So we are saying that cot alpha, which is this, is equal to what? Cos alpha all over sine alpha. So we're also saying that tan alpha is equal to what? Sine alpha over cos alpha. So now we are done with all what we need to note for the basic level. All what we have been discussing this morning. There are about 6 formulas you need to know before we dive into the study of trigonometry. But I should have given you the formula straightforward. That will just give us like 1 minute. I'll give the formula in 1 minute. But I just showed you how to derive the formulas, right? So in general now, for today's class, what we just need to know in general are 6 things. What are these 6 things we need to know in general? Number 1 is that sec alpha is equal to what? 1 over cos alpha. Number 2 is that cosec alpha is equal to 1 over sine alpha. Number 3 is that cot alpha is equal to 1 over tan alpha. All these things have been discussed. Check your book, you see them there, right? So number 4 there is that, okay, number 4 is tan alpha is equal to sine alpha all over cos alpha. And finally, okay, there are about 5. Finally, the 5th one, let me put it here. Number 5, the 5th one is what? Cot alpha is equal to cos alpha all over sine alpha. You need to know these 5 formulas. So know these 5 formulas, memorize them. These are what we're going to be using in the study of trig as a course. So for this class here, we're just trying to prove some trig identities. Some trig ratio you need to know, familiar with, right? Which are all this here. So in essence, you don't need to start cramming all the derivation we have just established earlier. What you need to know in this concept is just this. So don't mind the derivation, just master this concept. Sec alpha is 1 over cos alpha, cosec alpha is 1 over sin alpha, cot alpha is 1 over tan alpha is sin alpha over cos alpha, cot alpha is equal to what? Cos alpha over sin alpha. That's just it. Know this one. If derivation is confusing, all these steps are confusing, are too long, are too lengthy, don't mind derivation, just master this one, because we're going to be using this in the study of our course called trigonometry. So next class we'll dive into relationship between trigonometry functions, right? So see you in our next class. Bye. Also, if you're interested in joining our WhatsApp group, I just created a WhatsApp group. In that WhatsApp group, different from different countries such as India, Uganda, and every other countries can connect together and learn and share ideas. If you're interested in joining this WhatsApp group, I'll drop the link to the WhatsApp group in the description of this video. So check this on this video, you see a link to the WhatsApp group. See you in our next class.